Hello, I'm Miss Janet. Today I will talk about logarithms. Students may ask, what is a logarithm? A logarithm is the inverse operations to exponentiation, just like multiplication is the inverse operations to division. Addition is the inverse operations to subtraction. Sometimes we write on the questions about index, just like 5 squared equal to 25. 4 to the power 3 is equal to 64. 3 to the power 4 is equal to 81. This time we would like to find 5 raised to what power to give you 25, 4 raised to what power to give you 64. Consider the equation a to the power x is equal to b. The unknown is in power, so we would like to change the subject of this equation as x, so that x is equal to not base a of b. The small number is the base. The big number is the number of logarithm with respect to the base number. Now we can look for some examples. 2 to the power x is equal to x. The answer of x is equal to 3. We can write x is equal to not base 2 of x. And 2 to the power y is equal to 16. The answer of y is equal to 4. We can write y is equal to not base 2 of 16. These two questions are quite easy. You may say that no matter logarithm is applied or not, the answers can be obtained easily. So we can look on this question. 2 to the power z is equal to 12. Can you give me a number of z to satisfy this equation? You may know that the answer of z would be between 3 and 4. It is a decimal number. Then that's all. You have no any idea of this decimal number. When the answer is a decimal number, logarithms must be applied. Z is equal to not base 2 of 12. The answer is 3.59. Later on, I will show you how to use a calculator in logarithm calculation. According to the equation a to the power 6 is equal to b, when a is a positive real number, the power can be any real numbers to produce positive result b. Therefore, students must remember that the number using in logarithm calculations must be positive. Then I will talk about the properties of logarithms. We know that x to the power a times x to the power b, they are same base. The answer is equal to x to the power a plus b. When we present this in logarithm function, we would return as base x a times b and is equal to not base x of a plus not base x of b. There is a phrase for you to remember these properties easily. 合成分加，合成分加. Sticks together undergoes multiplication. Separations will take addition. How about division? When x to the power a is divided by x to the power b, they are same base. The answer is equal to x to the power a minus b. And this time we will write not base x of a over b is equal to not base x of a minus not base x of b. There is another phrase for you to remember these properties. 合除分減，合除分減. Properties of logarithms are listed here. For property 3, not base x of a to the power m, the power of a can move in front of the not as a coefficient. When the base number and the number of logarithm are the same, that means the small number and the big number are the same, the result will be equal to 1. And sometimes the base number can be omitted. This time the base number is 10. Not base 10 is a common not, so we can omit to write the base number. Another commonly used base in logarithms are the number e. E is a special number just like pi. E is a constant around 2.718. Logarithms to this base are called natural logarithm. We will use symbol ln to represent natural logarithm. The properties of natural logarithms are same as properties of logarithm. We just change log to ln. Now I show you how to use a calculator in logarithm questions. You need to check the model of your calculator first, because for some questions, different types of calculators have different ways to enter the data. There is a photo of a calculator. No matter which model you use, log and natural log buttons are in these positions in your calculator. If I do not have any special mention here, data will be entered in the same way of two groups of calculators. The logarithms in your calculator with base 10. Just like question 1, log base 10, we can directly enter log 2.4 exe. The answer will come out. In question 2, we do the question with the base is not 10. Students should pay attention to this question. For Group B calculators, should enter a close bracket after the number. You would enter you should enter the big number first and then followed by the small number. Just like enter not 5, divide not 3 and exe. In question 3, we will see ln in this question. That means we are doing natural logarithm instead of not. So we should enter natural log 2 and exe. For question 4 to 6, we would like to solve the unknown a. And in this type of question, this is very easy, just to add a shift button and then followed by previous process. And for question 4, the base number is 10. It is easy to get the answer. Just add a shift button. The answers can be obtained by entering shift not 1.5 and exe. And for question 5, the base is not 10, so properties of logarithms to be applied. A is equal to 5 squared, and the answer is 25. For question 6, we see natural log again. Just like question 4, add a shift button, and the answers can be get by entering shift natural log 4 and exe. You may try to use a few minutes to do question 1 to 6. When the power is an unknown, how to solve it? Question 7 to 10 will show you how to solve these types of question. For question 7, firstly, we will take logarithms on both sides of the equation. The power y can move in front of the log 3 as a coefficient. So the answer can obtained. Question 8 is same as question 7. Taking logarithms on both sides, and the power of y can move in front of log 5 as a coefficient. Now in question 9, we see ln in this question, we see e in this question. So this time we will take natural log instead of not on both sides. And the power of y also move in front of natural log e. Remember that natural log e is equal to 1. So we can obtain the answer. For question 10, 4 should be moved to the other side first. and taking natural log on the both sides of the equation. Once again, the power of y also move in front of natural log e, so that we can obtain the answer. Now you may try to use a couple of minutes to do questions 7 to 10. Finally, I will demonstrate how to convert a nonlinear function to a linear function. Suppose two variables x and y are correlated by the relation y is equal to 2.5 e to the power 0.3x. We plot y against x in a rectangular coordinate plane. The graph obtained is a curve. It is not easy to make an accurate sketch of the graph and use it to estimate other values. So when we taking natural log on the both sides of the equation, in this time, 2.5 and e to the power 0.3x are sticking together. So we'll apply 合成分加合成分加. Therefore, the natural log, this will change to the natural log 2.5 plus natural log e to the power 0.3x. And the power 0.3x can move in front of the natural log e. Natural log e is equal to 1, so we can simplify the equation in this way. By comparing to the equation of the straight line y is equal to mx plus c, natural log y is just like y, 0.3x is equal to mx, and the natural log 2.5 is equal to c. We know that m is the slope and the c is the y-intercept of the line. If we plot natural log y against x in a rectangular coordinate plane, the graph will be a straight line. Select any 2 points on the line to find the slope. We can find that the slope is equal to 0.3. And the intercept of the vertical axis of the line represents the constant natural log 2.5. Consider the equation. P and T are two variables. A and N are constants. We take natural log on the both sides of the equation. We have natural log P is equal to minus NT plus natural log A. Natural log P is like y, and T is like x in a straight line. By plotting a graph of natural log P against T, the value of A and N can be obtained from the graph. The graph of natural log P against T is obtained. Minus N is together with T, so minus N represents the slope of the graph. And natural log A is the constant, which is the intercept on the vertical axis of the line. I hope you can enjoy this tutorial. Bye bye.